because we don't have much time, we will go to the next talk by Yordan, who will talk about Singer without singing. I had no idea what Singer is before this talk. I'm not data engineer, but it sounds, if it works, it sounds great. So, Yordan, go on and show us the magic.
Awesome, thank you. So, here's how things worked like in my company, in the company I worked for about 7 years ago, just before we found out about Singer. We had like dozens of sources with hundreds of tables. And Spark pipelines held together by just enough glue to make refactoring dangerous. And you know, it kind of worked until we decided to migrate from Redshift to Snowflake. At this point, every single change was like a little nightmare. You can imagine like having 3 open tabs of the terminal, 5 more from the browser, and you praying to do the Stack Overflow gods. And you know, the situation is the same with probably 99% of the data engineers I know. Imagine like 30 to 50 bespoke Airflow scripts that you need to maintain just to keep the lights on. So here's the thing. If you want maintainable pipelines, you need a shared specification, something like a standard that allows everybody in the team to read, run, and change your scripts so they don't need any kind of tribal knowledge. And that's why you need actually standards. Now, here's the thing. Without a standard, every pipeline is actually like a small snowflake. You know, like onboarding becomes archaeology. Migrations, though, they're like every time, they turn into big rewrites. And then on-calls are like guesswork in the best case scenario. So, you know, you can probably imagine this. You've probably had this situation where you need to change one small thing, like let's say you want to add yet another destination to your pipeline, and what happens is that 5 other completely unrelated scripts fail because all of them rely on this weird merge statement, for example. So with a shared standard, what happens is that you can reuse, change, and even completely swap components because a standard basically results into predictable boundaries. It also means that your onboarding and reviews go much faster because everybody understands the shape of what you want to try, of what you want to do. So essentially, what I'm trying to say is that I don't really care how clever your pipelines are if nobody can run them at 2 a.m. I mean, so clever that only one person understands them is not really an asset. It's a liability. So actually, you need to make your choice really right now. Do you keep rewriting every time, or you agree on a shared contract and you stick with that one? So now let's talk about really what Singer is and why I recommend this specific standard. You can think about Singer as a lightweight contract for streaming JSON data, a protocol if you wish. Here on the left side, what you have is a tab. Those are the scripts that connect to your source systems, and they're responsible for emitting 3 JSON messages. First, you have and that all happens to the SDL, to a very standard interface. First, you have your schema messages. Those explain essentially how your tables look like, data types and all of this. Then you have the record messages, the actual data, and finally you have your state messages. Those are checkpoints for incremental loads. Then on the other side, you have the target. This is my left, your right. So the target scripts, which connect to the destination, and they are responsible for reading those JSON messages from the stdin and loading your data reliably. So, as you can guess, as you can see, I haven't mentioned any tools or anything like that, because Singer is not a framework. It's not an SDK that you need to buy into. It's not an orchestration tool, and certainly not a transformation tool. It's the contract about the shape of your messages and the order you send those. It's it's like a I like it because it's very lightweight, and every single script that talks this language, if you wish, those scripts can talk to each other. Essentially, you can connect every single source to every single destination with minimal effort. So that's really it. You have a small spec, but with massive leverage. Now, I must say that Singer is just for extract and load. Singer is like the pipe, it's not the processor. It means it doesn't care about the transformation layer. You need to run your transformation somewhere else, maybe dbt, maybe SQL scripts, or whatever. It means Singer is specifically designed for ELT workloads and not ETL workloads. And one more note. When I say streaming JSON, I'm not talking about real-time pipelines. In fact, most people run their workloads, run batch workloads, right? So here we only talk about the protocol, the language if you wish, and not the approach. Now, let's dive deep a bit and see what we're talking about. First of all, the specification, as we said, defines those tabs and targets, those two separate kind of scripts that you need. The first part is the tabs, and those scripts are responsible for authenticating to your source, discovering and emitting those schema messages, emitting the actual records, and finally emitting reliable cursors for incremental loads through these schema to these state messages. Then you have your target script, and its responsibilities are to ensure the destination tables exist, and that means also creating and altering them. Then you have the other responsibilities are to map data types consistently, observe the records, and obviously then store the state. So next time when you rerun that pipeline, you don't start from the beginning. So, when something breaks, you know actually where to look at. You only need to check whether your tab speaks correctly or your target listens correctly, and you eliminate any mystery in the middle. And now you have the second part of the Singer specification, the three types of messages. First, we start with the schema messages, the JSON messages. You have three main things here. The first one is the stream identifier. Usually that's something unique for the whole pipeline. It would be, in my experience, I personally like to have the source name and the table name, for example, Postgres accounts. And then you have the schema, which holds the actual information about how your source and therefore destination table needs to look like. That means you have column names, data types, any kind of constraints, like can this column have null values or should it be unique, all kinds of constraints. And finally, the schema messages holds key properties, like the primary key, let's say an ID, or which key you use for incremental loads. Let's say that would be updated at. The next message in this Singer specification is the record. Here you have two main things. You have the stream, again, the unique identifier, and the actual data encoded in JSON format. So you have, let's say, ID1 and name John. Here, it's important to say that you need to emit just one schema message when you start syncing your pipeline, but then you emit a record message for every single record that you need to sync. So if you have one record, it equals one message. But if you have 1 million records, that equals 1 million messages. And finally, we have the state message. The state message essentially collects all the streams for your pipeline in a single JSON file, in a single JSON message, but you have the latest incremental values for every single stream. So it means, let's say you sync the Postgres accounts and Postgres users. For the accounts you might have, the latest account was created, let's say today at midnight, but the latest user was created this morning at 7 a.m., for example. So you have all of these, which means next time when you start the syncs, every single stream only pulls the data that's new for this stream specifically. Now, what's next? The next thing is the Singer files. Now, you don't need this. Singer doesn't specify the files itself. But in my experience, what I found is that having some configuration, things like this, helps a lot. First, you have the config JSON file. Here you define endpoints, you define different toggles, credentials, all of these things. And then you have the catalog JSON file. In the catalog, what you have is the streams that you want to sync, the actual schema, again, column names, data types, and all of these. And you have also your incremental keys and all of these things that we just mentioned about a minute ago. Finally, you have the state JSON, where you save where you are at with your pipeline, with your syncs. Now, I must say that in my experience, I have never seen somebody actually having these files committed to their repositories. What you'd usually have is you'd create those in the runtime. So that means, you can definitely have a file where you store some toggles, some flags, but essentially what you'd have is you'd create those files in the runtime. For example, with credentials, you absolutely don't want to keep this in your code. You'd have them in the environment variables. So before you start the pipeline, what happens is you put those credentials, you put those flags and all of this information, create the file in the runtime, and pass it to the target. Same thing with the catalog. Let's say you talk to a Postgres database. There's zero sense to store the schema of your Postgres database in a file when you just can pull that information from the database, from the information schema, create that file, and again, pass it to your tap script. So the idea is that you will never actually use these files, but they help in the runtime. And here's the thing. If you use Singer without any wrappers or any files, it's extremely easy to use. You only use standard interface. You use normal Unix pipes, really. In this case, that's how you sync data from your Salesforce instance to your Postgres instance. And here's the power. If you want to change that and you migrate, let's say, from Postgres to ClickHouse, all you need to do is to just change that second script and run tap Salesforce pipe target ClickHouse. And that's the big power of Postgres. You have those two separate things that talk to each other, and you don't care about the interface. It's there and it works. So let's make it a bit more real. Let's say you have a paginated API that you need to pull this data from and push this data into your, again, Postgres database, for example. All of that happens incrementally. You only need the new data by using the updated at column. So what you do is you have the tab, and its behavior is the following. it authenticates to the API using the token, then it discovers the schema, selects all the streams that needs to be synced, and requests the data using something like where updated at is greater than the latest bookmark. Then the tab emits all these record messages. And finally, after each page, when the page is printed essentially, you emit a single state message after each page. Then you have your target script again, the tab, and what happens is this tab ensures the schema exists, right? The tables exist. It maps all the data types, observes by primary key, and finally it persists the state consistently somewhere. To test this whole thing, what I'd recommend is to kill the pipeline mid-run and restart it. It should start from the state. If it breaks, you know where to look at. It's either you need to fix either the tab or the target. You don't touch the middle. You don't touch the interface. That's really it. And here's let's talk more about the ecosystem. The thing with having an open specification like Singer is it also means that you have a ton of plugins, open source plugins that you can pull from. You can certainly look into GitHub or PyPy, for example, but this is the most comprehensive catalog I've ever found, where you can find a ton of things. So let's say you want to start pulling data again from Salesforce or HubSpot or whatever, and again want to push that to Postgres or Snowflake, Databricks. You just pull these things, read the documentation, and it's extremely easy to run them. So this is my favorite catalog, really. You can find a ton of scripts here, literally hundreds of tabs and targets. But here's the thing. You will still need to write your own code. Having an open specification means that you can write things for, let's say you want to change something that you put, like a pre-built script, or you work with a very niche connector. So following this, you can build your own tabs and targets. My recommendation is to use one of these two approaches. The first one is the, so to speak, official lightweight library, the single library, where you need to code everything by yourself, and it only takes care of printing out the messages for you. The other approach is to use the Singer SDK, which is not so lightweight, so to speak. It's still Python, but has a lot more things. It has the benefit of you not needed to think about how to authenticate to APIs, for example, and you just need to fill in the blanks. However, the learning curve is a bit more steep. So my recommendation is, if you want to dive deep into Singer, start with the lightweight library, and only then, after you are more confident about how things work, then you hop to this Singer SDK. Now, I guess let's recap. First of all, Singer is not about having a tool or a framework. Any specification like that is not about that. It's not about performant pipelines. It's all about having performance within the team, about having clarity and consistency. It's about onboarding people quickly, understanding what happens, and having all these quick code reviews, if you wish. So that's really all about Singer. I don't want to show you exactly how it runs. I don't want to show you code. It's all about, it's you who need to understand that, but it's extremely easy. I strongly recommend that. Now, if you have more questions, definitely reach out, check with me. You can look for me on LinkedIn. I'm Yordan Ivanov. I post there probably every single day. And also you can find the link to my newsletter. Now, I'd be happy to take some questions, really. Who's the first one?
How does Singer compare to other frameworks such as Airbyte and Fivetran as well?
That's a very good question. So Fivetran, first of all, it's a tool, right? It's a software service, which means you need to pay a lot. Singer is a specification that is open source, so you need to run it. Basically, you can self-host it. Airbyte, and there's a lot of tools actually that also support Singer. You know, you can use Meltano, you can use things like Mage, which is very hot now, and a lot of other things actually use Singer in the background. Singer, by the way, it came out from another software service, and they found out that if they open this specification, it would be very helpful for, first of all, for the community, because now it's de facto the standard for anybody who doesn't want to write bespoke scripts, but also it helped this company specifically because people started writing connectors themselves and contributed to the company. So it's very different. I mean, one is for running on a service, and the other one is if you want to run them yourself. Yeah, does that help? I hope it does. Awesome. What's next? Okay, yeah. Yeah, great question. So the question is basically how you link everything together. If you have Singer just for digestion, how you run the transformations and everything else. What you would usually do is you still have an orchestrator like Airflow, where you run your Singer pipeline, you pull the data, and when you're done, you run something like dbt. That's what we do in my workplace, really. So it's very, very simple. Well, I guess if that's everything, thank you so much. I was quick, and that was my goal. Thank you.